right, boys and girls, it's Mrs. Bartel back for some more math. Today we're going to be going over the first page of the Unit 6 review. I want to make sure that you've tried to do the first page before you sit and watch this video. So if you have not attempted it, I want you to pause the video and actually try to do the work prior to watching this. All right, so I'm going to read the first problem. Liana plants a vegetable garden in two sections. So two different parts. Already I have a visual in my head of two different rectangles is what I'm thinking. She plants corn in a section that's 5 meters long and 6 meters wide. So a 5 by 6, okay? And then she plants squash in a section that's 3 meters long and 6 meters wide. So a 3 by 6. All right, so part A, describe one way to find the area and then actually find it. Part B, drawing the picture. So to actually be able to find the area, do you need me to stop and redo my video?
It's up to you.
The termite people are here, boys and girls. I have termites. It's real life. I'm not going to stop. Okay, so the first thing you need to do is to draw a picture, because that's how I always do everything, is drawing the picture. So I would draw a picture of a 5 by 6. So this is going to be 5 feet by 6 feet. It's a 5 by 6. And and by the way, these are meters, so M. I'm going to go up here and try to remember what that was. I lost my train of thought. Corn. This is going to be the corn. So if you look at 5 groups of 6 for this array, and you were trying to figure out the number of squares, that would be 30 square meters for the corn, for the area. And I'm going to put in here that that's the area. Now, the squash was in a section that was 3 by 6. So 3 by 6, like this. And I'm going to write that this was the squash. There we go. And that's 18 square meters for the area for this part. Okay? So she's going to have a lot more corn than she is for the squash. And squash is like zucchini, and then sometimes in the summer your mom might have like yellow squash. So that's kind of what this is here. Okay? So now that I have my pictures, and I actually did some work here, describe one way to find the area of the garden. Well, here's what I would probably be writing up here. I would have definitely done this work first, draw the picture, okay? So I would write up here that I drew a picture of the rectangular area for corn, and then I drew the picture for squash, and then I calculated the area for just the corn and the area for just the squash. So I would mention that up there. Okay, and then what you're going to do, they want to know, of course, the area of the entire garden, boys and girls, not just the section of corn and not just the section of squash. So then I would go on to say that I combined the area of 30 for the corn and 18 for the squash. And when you add up 30 and 18, think about what you're going to get there. It's 48 square meters. That's going to be your answer here, 48 square meters. But I just verbally went over how I would do that. So find the area of each section individually and then add those areas together. Okay? All right, so on to the next page. A park ranger has 32 feet of fencing, and he wants to fence 4 sides of a rectangular recycling site. What is the greatest area of the recycling site that the ranger can fence? And explain how you know. Okay, So the fencing, it's 32 feet. So that, now fencing, boys and girls, is going to enclose something. So that's going to be like the perimeter is going to be 32 feet. So when you add up the whole, I don't know, let's look just at this picture right here. If this was the area that he's fencing in, right, for the recycling site, all of that adds up to 32. So think about what we know about finding the greatest area when we have a perimeter. Okay, do you remember how we did that? The one that had the sides that were closest together, closest to a square, that was what had the greatest area. That was a few lessons ago, but I'm pretty sure it was the one that was as close to a square as you could get. So if I'm taking, remember how I started doing this? I took the number and I divided it by 2. So I'm going to take 32 and I'm going to divide it into 2 equal pieces. And that's 16. Now that's just like pretending that that's one of these side lengths. I know for a fact I cannot have 16 here and 16 here because that's 32 and then I would have 2 missing sides. So I cannot use 16 as a length. I can go 1 down from that. Okay, so now I could have one of the side lengths could be 15 and the other one could be 1. I could have 14 and 2. And I guess I should explain just in case some of you are confused. But if you were to add up 15 and 15, that's 30. And then the 1 and the 1 and this is the 2. So then that's 32. Same with the 14 and the 14, that's 28. And then 2 and 2 is 4 and 28 and 4 is 32. So that's how I'm coming up with these numbers in case you're confused. So I could go down 13 and 3. I could go to 12 and 4. I could go to 11 and 5, 10 and 6, 9 and 5. Or am I doing, I think I'm losing count here. 1, 2, 3, 4, 5, 6, 9 and 7. 9 and 7. And then 8 and 8. Now, boys and girls, remember, the 15 by 1, that's going to be a long, skinny, right? 15, 15, 1, 1. Think about the area of that. The area of that is going to be 15 times 1, right? It's going to be 15 square feet. We're in feet here, okay? So the area for this one would be 28 square feet, okay? So it's larger, isn't it, than that, okay? So remember, the long skinny, right, the one where the length and the width are farthest apart in distance or in length, side lengths being equal to each other, that's a little confusing, sorry about that. This is going to be the one with the least amount of area. So the one with the greatest amount of area is going to be your 8 by 8. So that is how I came up with that. So you can find the area of each section of a garden and then add those areas together. The greatest area is going to be the square. 8 by 8. Okay? So square feet. And once again, the closer, like the length and the width are to each other, the greater the area is going to be, okay? The farther apart the length and the width are from each other, the smallest the area is going to be. And this is for any rectangle with the same area, okay? So I would say that I would do an 8 by 8. And again, I would just say that the greatest area is going to be the rectangle that's closest to a square. And this one is a square. It's 8 by 8, okay? All right, that's it for that one. Hopefully you guys get that. I would probably have drawn a picture of these on separate paper if I really were to be doing this. in class with you, I'd probably, because we would have graph paper, boys and girls, and I'd probably have you draw several of these out before we came to that determination. Hopefully, when you were trying to do the test independently, you tried to work some of those out. All right, this says that we have a hexagon divided into triangles. Think about what kind of triangles those are, boys and girls. We talked about them with all the side lengths being the same. Those are equilateral triangles, right? So a hexagon has 6 sides, right? 1, 2, 3, 4, 5, 6 sides. Let me erase these little marks. 6 sides. It's been divided into triangles with equal areas. What part of the area of the hexagon is the area of each triangle? Well, there's 6 equal parts, boys and girls. So if you're dividing it into equal parts, right? Equal parts. It's like fractions. So 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 equals 6/6. So what is each little section here? The answer would be that it's 1/6. Okay, 1/6 of that area. Okay, this octagon has been divided into triangles with equal areas. The area of each triangle is 2 square units. So, and what do you know about an octagon? There are 8 sides, right? And each little triangle they're telling you is 2 square units. So 8 groups of 2 would be 16 square units. That's how you would figure out that one. All right, boys and girls, that's it for this page. Hope you did well.